Alright, this gets us to the last section in chapter 2 on variation. And we have actually 4 types of variation that we typically discuss, but we're going to only discuss the 3 of them in this particular section. Direct and inverse variation, and of course students' favorite one to make fun about, joint variation. But we'll start with direct and inverse variation. Let k be a non-zero constant real number. The statements below are equivalent to the equation next to them. So in here it says y varies directly as x, or y is directly proportional to x, gives us this equation here, y equals k times x. K there being that non-zero constant, which we're going to call the constant of variation. The second form, y varies inversely as x, or y is inversely proportional to x, gives us y equals k over x. Now notice in this direct variation, as x gets bigger, y gets bigger. But in inverse variation, as x gets bigger, y gets smaller. Okay, the more you study, the higher your grade, the higher the price on the candy bars that you sell, the fewer the cost, the fewer that you actually sell. So you have direct and inverse variation be the 2 main types. You'll need to memorize these guys to go with them. And again, k is a constant of variation. So the first 3 examples we'll just write out the equation that models it. Write a variance model using k being your constant of variation. The distance d that a spring stretches, notice here, varies directly as the force, I'm going to assume then we'll use F here for the force, applied to the spring. Well, it says here direct variation, so the distance d varies directly, there's my constant, as the force. There is my equation that models this particular problem. Part B, the force F required to keep a car from skidding on a curved road varies inversely as the radius of the curve. You guys have done any driving? The tighter the curve, the more difficult it can be based on your speed to keep the car from skidding off the road. So in this case, we look for the key here, and that is inversely, varies inversely. So our equation, I'm going to put it above right here because I didn't leave enough space below. The force varies inversely, so k goes in the numerator to the radius of the curve. Now I didn't write it down again, I'll just call the radius r here. And this would be the variance model for this problem. Up here, the variable a varies directly as b and inversely as the cube root of c. Now in this case, there's direct variation and there is inverse variation. Some books call this combined variation. So A varies directly as B, which means that it's kind of like in the numerator there. So this would be k times, k being our constant of variation, times B. And inversely, now inversely, notice it's going to be in the denominator, k is up top in the denominator, as the cube root of C. So the cube root of C. So a little practice, you read them, you write them as you read them. It's not that bad. Look for the key words. Varies directly, varies inversely. And of course, joint variation, let k be a non-zero constant real number. The statements below are equivalent to this equation. That's to the right there. Varies jointly, y varies jointly as w and z, or y is jointly proportional to w and z. Notice it's kind of like direct variation. It's in the numerator, it's not in the denominator, but there are 2 variables here that are involved. That's the name, the joint variation. So we'll try that in a couple of examples. Write a variation model, again using k as our constant of variation. Kinetic energy, E, of an object varies jointly as the object's mass m and the square of its velocity. Energy, the kinetic energy, varies jointly, so that would be k times the mass and times this, in this case, the square of the velocity. All right? Z varies jointly as x and y. Z varies jointly as x and y. There's my constant of variation. And inversely, so in the denominator, another example of combined variation as the square root of w. So the square root of w in the denominator. It's not so bad. And you can use these to actually solve problems out. Now you may have to first find k, the constant variation, and I have 3 examples of that. The amount of medicine epsilon that a physician prescribes for a child varies directly, that's important, varies directly as the weight of the child. So the amount of medicine, I'm going to say A for the amount of medicine, varies directly with the weight of the child. So I'll use W for the weight of the child. So I have A equals K times W. Now that's going to model that, but I don't know what K is. A physician prescribes 450 milligrams, that would be the amount, for a 35-pound child, that would be the weight. See, this sentence right here is going to give me enough information that I can figure out what K is. I'll plug 420 in here for the amount of the medicine, and 35 in here for the weight of the child. Now I'll solve for K. I'll divide both sides by 35. And let's see, that's going to go in 12. So that means my constant of variation for this circumstance, for this particular application, is 12. So I can rewrite this as A equals 12 times W. In many cases, you'll see problems set up where that's all they want is to know that constant of variation and then write out that variance model. But we're going to go a little further. How much should be prescribed for a 40-pound child? So we're going to plug 40 in for the weight here. A equals 12 times 40, or 480. So there should be 480 milligrams prescribed. Now if you're looking at this and you're saying, I would probably just set up a proportion. Well, I kind of did a proportion. I just did it in a slightly different manner. But yes, you could get this with a proportion, all right. I did definitely want to know that this was 12 to kind of follow through with the flow of the problem. And again, sometimes they'll ask for the constant. You're not going to find that quite so readily if you set up a proportion, maybe just one of the ratios. Second example, the yield on a bond varies inversely as the price. So I'm going to say yield varies inversely as the price. I'll use Y for yield and P for price, and I have that model. The yield for a particular bond is 4% when the price is 100. The yield is 4% when the price is 100. So in this case, I'm going to plug in 4% here, over here for Y. So I'm not going to write 4%, I'm going to write 0.04 equals K over 100. Well, that was kind of convenient, that was 100, because if I multiply both sides by 100, I get K is 4. And I can plug it back in. I haven't even read the whole problem and I'm halfway home. Find the yield when the price is 80. Find the yield when the price is 80. So Y would be 4 over 80, which would be what? 1/20th? Y is equal to 0.05. So the yield is 5%. Writing the decimal as a percent. This last example, I'm not 100% sure I left myself enough space. I may have to erase a little bit of this here next to it. The amount of simple interest. Now I know if you're thinking simple interest, I equals PRT, absolutely, that's simple interest. Earned on an account varies jointly as the interest rate, the R in P equals R, I equals PRT, and the time, which of course is T for the investment. So I'm going to set that up here because it says it varies jointly. I'm going to say that the interest is equal to K times RT. Now again, if you know the simple interest formula, in this case our constant of variation is the principal. It says here that an account earns $200 in 2 years at 4%. An account earns $200 interest in 2 years, time 2, at 4%. So I have 200, yeah, I don't think I'm gonna give myself here near enough space. 2 times 0.04 is 0.08. Let me erase a little bit of this just in case to finish this problem off. I'm going to divide both sides here by 0.08. Hopefully you can see this okay. I flip-flop the sides. And I have 200 divided by 0.08, and if I'm not mistaken, that's 2,500. So apparently that was my principal. So now I can write it, and I'm going to come up here as I equals 2,500 RT. Then the question says, how much interest would be earned in 3 years at a rate of 5%? Well, if they just asked you to find the constant variation and write the model, you'd be done, but there's a little bit more being asked here. How much interest, I, will be earned in 3 years at a rate of 5%? So I is equal to 2,500 at 5%, 0.05, times how many years? 3 years. So now I need to multiply all this together, and if I'm not mistaken, I believe it turns out to be 375. Which kind of makes sense because it's longer invested and it's at a higher rate. This was only $200, so it definitely needed to be more than 200. So there will be $375 in interest. It is an application, so you should write the answer out in a short sentence.